Okay, as I said, afternoon everyone. Thank you for choosing this segment. This is the first time I've presented this material, so you will have to bear with me if there are any hiccups. Hopefully, I'm going to be able to give you an overview of SPLUNK UBA, User Behavior Analytics, and how it can be used for machine learning for threat detection. So first and foremost, I'm an alumnus of Napier University. I was Bill's student and several other lecturers of the university, graduated in 2013, and then started working for ECS, which is a predominantly Edinburgh-based consultancy specializing in computer security. And we work all throughout the UK, predominantly in financial services. If any of you were at Steve Livingston's presentation, you'll know that we run their managed SOC, their Security Operations Center. And over about the last 18 months, I've been predominantly working on the SPLUNK toolset, the platform for big data, and looking at how it can be utilized for security-based use cases and to improve organizations' reducing their exposure to cyber attacks. ECS, I think it was last month before, we were voted SPLUNK's Partner of the Year for UK and Ireland for security, which was a great achievement for us as we're such a small organization in comparison to some of our competitors. And so because of that and because of our close strategic partnership, we've been going on some really interesting boot camps and getting access to one of their newest tool sets, which is User Behavior Analytics. As you all know, the reason we're here, big data is huge. I'm not going to show you tons of stats about how many emails a second and so on. We all know this. It's a fact. Big data is here to stay. And the most interesting part of big data is machine data. Machines generate logs. You know this. Computers do, fridges do these days, vending machines, your mobile phones, your tablet, your smartwatch. All of these things generate hundreds, if not thousands or hundreds of thousands of discrete logs or events per day. The challenge, of course, is what do we do with that information? The challenge has been for big data tools for probably last 7 to 10 years is, first of all, being collection. How do we actually build tools that can grab it all in? We started doing it with databases. That didn't work because there's only so large a database can go in the vast majority of infrastructure before it simply gets too big, or it's unserviceable, or it's not replicated, you lose your high availability. So we moved to using more Hadoop and MapReduce type technologies, which is what SPLUNK and other tool sets of that kind use. And so we've got that down. We're able now to collect data from most sources. We can pull databases, we can get binary log files, we can get it from exports of NCase, we can do all kinds of interesting things with collection of logs. And this is great. This enables us to do correlations, it enables us to produce events of interest, as you heard in the previous, some of the previous presentations, and we're getting tons of them, which is fantastic for a security function or team. But it also presents us a problem. And this is my problem statement. This is saying that essentially the legacy SIM type technology, the big data tools that we have, they simply do not do a good enough job of getting that information down to actionable information, actionable events, things we can actually take response to. There's so many stats and surveys and stuff done, but one of the key ones I've pulled out is first and foremost is context. So a legacy SIM will say, oh, someone tried to access this website, and that is blocked on the proxy, for instance, or it's a warning. Or maybe someone downloaded some data from a site they're not meant to. And that will generate an alert, which is great. It's a lot more insight than we used to have. But what happens when it generates 20,000 a day? Even the largest banks in the world don't have security teams that can look at individually 20,000 alerts a day and actually not just close, bulk close, select all, close, false positives. And this is a really, really stupid problem to have, but we have it because it's actually really hard to train a computer to be able to do that job. We can do it to a point, we've got rules, we've got tons of clever ways of doing it, but actually it's not working. And it's not working because, as you've heard, there's been multiple breaches where they had the tool set. They'd spent the millions implementing it, the professional service costs, the license costs, but the weak link was the analyst's time. They didn't have the time to analyze, to look through all the logs, all the events of interest. As we've moved through the last 20 years or so with security, first and foremost starting at the endpoint, where we had antivirus or perhaps basic host-based detection of intrusion. And then we moved through network security, access control lists. We started having rules. We could set thresholds. We then eventually said, well, great, now we've got big data that came in, so we could correlate. We could say, okay, now I can say, well, this happened in this device, and something else happened on this device, and that means something, and that means something interesting. And that then became SIEM. And SIEM became, if you have that, and that correlation occurs, I would like to know about it, because I'm going to get someone to look at it, review it, triage it, and then hopefully take action. And that works, again, to a point, but not when you're throwing the data sets in the environments that we are these days, not when you're taking, I believe one of the stats earlier was 20 billion Internet of Things-based devices, each one of them generating hundreds, if not thousands of logs. And where we need to move, and where the industry's been moving for a few years now, is to say, we need to get the computer, the machine, to be much better at understanding that process. We need to create models and algorithms that allow us to take apart these data sets, rework them into something actionable. Those of you familiar with the kill chain, which is basically a framework allowing you to understand the actions of an attacker, will know, and so it's excellent. It allows me to map, well, this event happened at this part of the kill chain, and this event happened at this part, and I can tie them together, but there's just too much. There's too many discrete log sources. There's too much training needed to train an analyst to understand each and every device and what that log might mean. Having analysts looking at event payloads and actual log files, that's a really inefficient use of their time. And even with all the correlations and taking those billions of events down and transferring them down to only a few thousand a day, it's still far too many to take any form of action at scale. You can't do it. And we continually fail to do it. And there aren't many tools or platforms that are working towards it. We're trying, but we're currently not doing very well. Oh, thought someone had a question. It's okay. So, as I said, ECS, my employer, we work very closely with SPLUNK, which is a big data platform. It's great at collecting data at scale, up to petabytes a day, across your infrastructure. And it's been looking at security for quite some time. It's got a SIEM tool that sits on top that enables you to do a lot of really cool stuff, very competitive in the market. Gartner rate them as one of the highest in the area as well, alongside IBM and HP. But what they've been trying to move into, and what they did last year when they bought a small startup called Cuspida and turned it into Splunk User Behavior Analytics, is they wanted to take that SIEM legacy that we've built and we've got and is in so many of our large enterprise environments and even now smaller businesses, and say we need greater levels of intelligence. And the way to do that is via machine learning. Now, machine learning, as a very basic, I'm not an expert on machine learning itself, but as a basic understanding, what machine learning is it's taking your data sets, which have been collected, it's pulling them through a number of different algorithms. I don't remember at last count, but I'm sure there's hundreds of actual discrete machine learning algorithms. And then it's taking what you've learned from that, from your statistical analysis, from looking for outliers, for looking at things that don't accept that are anomalies based on your behavior analytics, and pulling it through a model. And those models are things like, I want to understand what data exfiltration looks like, which is when data leaves your environment. I want to know what lateral movement looks like, which is when someone or something has an account on your system and it moves across into another zone or into another system or into another application stack. We've had machine learning in a supervised way for some time, but it involves a lot of tweaks. It involved teams of people looking at it, constantly tweaking the models themselves, and it usually involved people with PhDs in machine learning. They're actually really hard to find, so if any of you do have that, please do talk to us, because we'd be really interested. But now, unsupervised is the key term here. It's moving to models that understand the data well enough that they adapt and that they take those millions of events, then those thousands of anomalies, and pull out 3 discrete threats that you should react to. 3 discrete threats that your analysts should escalate through incidents and go, this is what's happened, this is what we see, and this is what you need to do about it. Because as we know, without that ability to respond, almost everything else is worthless. Because if you can't respond, if you don't have enough information to do something with it, what's going to happen is they're going to close it down. Oh, here's an event. It says someone tried to log into this machine. Does it give you a user ID? No. Useless. Great, someone logged in. Who? Irrelevant. You need things that you can assign intelligence and understanding to. SPLUNK UBA is designed for 2 particular cases. They're quite broad in themselves. First is advanced cyber attacks, which I'm not going to start going into very much because I think we've kind of got a good handle today on the vast different types of attacks. But then there's the insider threat, often referred to as the invisible threat, because so many organizations don't understand their users. They don't understand how their users behave. They don't understand how their users act within their systems. And therefore, they're often blind when those users do things that they shouldn't do, whether maliciously or not. Hopefully you can all see that, but this is basically an example of an insider threat. This is trying to show you how each one of these points that John has done in the environment will have generated hundreds, if not thousands, of events. And our legacy tools can detect that. We can say John logged in over here and he did that over here. What we lack is often the ability to tie all these things together into a risk understanding and say, because of all these discrete events happening, because of them happening within X timeline, and how different that is to John's normal activity, that is a problem, that is a threat. And you can say with a high degree of certainty that something is happening that shouldn't be. And that's the key. Because each one of those events, or the majority of them, they may have legitimate cause. They may be okay. But when you combine them into a threat or into a grouping of anomalies, you start to draw conclusions in which you can respond to. And the way SPLUNK User Behavior Analytics does this is not just by understanding the user, as the name might suggest, but it does it by understanding multiple entities. And an entity, as you can see, is either a host, so that's a device, it's a network segment or a network device, it's an application stack, it's perhaps a data set, if that's hopefully being classified, where it's your confidential data at different levels, and of course it's your user. And by understanding how each one of these entities behave in a normal scenario, you can say, well, that's normal. You know, John's a member of the Unix admin team. It is normal for him on an average day to log into 200 devices 30 times each. Not a problem. But if you see someone from HR doing that, you want to know. That kind of differentiation, that kind of understanding of peer grouping is hard to do in legacy big data tools, because without running continual real-time searches, without having a huge amount of hardware behind it, constantly running those searches and correlations, you're not going to get that information because it's not going to tie it together. So I'm going to hopefully, I was going to show a demo, but unfortunately I can't get access to the demo environment. So fortunately I took screenshots this morning to make sure that I could still at least show you something. This is SPLUNK UBA 2.0. There we go. Right, let's see if that will display. Great. So this is the front dashboard of UBA. This is just giving you an assessment of your current security exposure. I'm not going to go into it in depth because I want to actually show you one of the threats. But essentially, this is showing you in a traditional SIM type way, what things should you be interested in, what devices are polling out, what anomalies are there. And the most important, the one on the left, is what are the threats? Now, this is built all around a large amount of test data that's been put through all the models, but it should hopefully demonstrate some of the value within there. So if you now imagine that I've clicked on threats, and in a very nice, Web 3.0 kind of way, it's transitioned to the following screen. So this threat is data exfiltration, and it believes it's via malware. Notice that all of the natural language used in the top part, which is great for perhaps people that are not that technical, that may be reviewing the screen, they have a very simple explanation of what is this threat? What does this mean? Well, this is what it means, okay? So what is the timeline? Straight away, from the first event that's been mapped to this model to the last, it tells you the timeline of events. It gives you a list of all the anomalous type behavior that has led to this threat. It gives you an understanding of who are the users impacted across this entire threat. And then finally, obviously, the devices and the domains. In the top right-hand corner, the 6, this is a risk score. I don't know. Oh, they're coming up okay, good. This is how it started to do that risk modeling, how it's doing that risk scoring by saying, okay, because this threat's launched, but some of the stages don't have much data, but it also has a high number of anomalies, it's a 6. There's a logic there. There's a logical progression of the type of anomaly, how that's been rated individually, and then there's an aggregate risk assigned to it. Not very important if you can't read the IP addresses, but basically what this shows you is how it's all mapped together, the relationship. Why is this all part of the same threat? Who's to say they're connected? Well, this shows you the commonality between them. It shows you the user at the top, Chris, on a ton of different machines, has gone out to some malicious domains and potentially got some malware back. It shows you then that 2 other users have done the same across 2 machines, but all of them have got similar behavioral characteristics in common. My favorite, the kill chain. When I was an analyst and an incident responder, one of the things that we did often was look at the kill chain and how that mapped to our incident. At what part are we in the kill chain? And when the operational managers and the security management team started to hear the word kill chain and they understood what it was, the first question, where's this incident at in the kill chain? Where are we at? Have we lost anything yet? They were full of questions. Now, I'm not saying that one single tool can always answer all those questions, but when it's displayed like this and it's tied all those anomalies in, based on the machine learning algorithms, it can give you an idea of, with a degree of certainty, here's where we are. Here's the timeline of events. Here's where it started, where we believe we were compromised. Here's how it moved through the environment, with finally, what was the outcome? Well, we believe data was exfiltrated. Further down, it's got the mapping of how these relate to time. I'll skip over them quickly because we're short on time, but essentially, as much information as you want, you can drill down into. If I go down into the actual first event where it says that someone received some malware, there's the stage, the initial infection stage. I click into it and I get all the information. I find out, well, why has this been flagged? Again, I can answer the why. How do we know Chris's machine was affected? Well, the log data is there to say, well, this is why. And these things appeared on a blacklist. Moving back to and also I've got the trigger and event, the geolocation information if it's included in your logs, and also the anomaly graph of what other things has this impacted. The lateral movement stage. So when this account has potentially been hijacked and the data is showing us that it was. Here you can see on the graph at the bottom, it's normal for Chris to log in about 30 times a day, locks and unlocks his computer 30 times a day, and then suddenly there's a spike of 1,700. Now again, on its own, that might be an indicator of misconfiguration, of a user who's really, really bad at remembering their password. But it's much more likely to be an indicator of compromise. It's much more likely to be an anomaly that you want to know about, but you want to know about with context. The context is that Chris's machine was suspected of visiting a site that contained malware. 2 days later, Chris's machine starts logging in an abnormally large amount of times in a day. Tie it together, you move forward, you move through. Now Chris is accessing machines he's never accessed before. In the entire data set, this user's never gone on these machines, never tried to log into them. Again, very unusual when tied with what we know about what Chris has been doing recently. Finally, Chris's VPN access, what he transfers over the network in an average day versus what he's done recently. Again, on its own, maybe he accidentally transferred a couple of disk images or a few torrent files. Not good, but not necessarily a massive breach. But when you tie that together with everything you know, I would probably say as an analyst or incident responder looking at all these indicators, that either Chris has become a threat and he's trying to exfiltrate data, or more likely, because of the nature of the events we've seen, he's been the victim of an account hijack, and his account is now being used to try and exfiltrate data. So that is the end of the demo. I will just go back a little. So very briefly, these are the things that came out last week with UBA. Some people asked me previously today, does it support creating your own threat models? And it does. It didn't, but it does now. It enables you to take all the anomalies and say, well, when I see these together and these together and these together, I want X. It also allows a huge amount of more third-party devices as far as inputs and correlations. And I think that's it. Any questions?
Thank you very much, Harry. Do we have time for maybe a couple of questions, perhaps, if the audience has some questions?
Do you think this behavioral analysis may eliminate the need of having skilled analysts who actually do the job right now?
So I don't believe this type of product and the machine learning will void the need for skilled analysts. I think it might remove some of the need for the level 1 analyst, for someone who's early on in their career, who is just there currently clicking false positive close, who's not actually learning very much because all they're doing is dealing with all the false positives or the unactionable true positives and events that they're getting. An analyst should see something from its tool set and say, action, I need to do something other than just close a ticket.
You mean for now, or do you see in the future?
No, I think in the future. I think at the moment, yeah. I mean, we're a way away from that. But ideally, the whole point of machines is to make our jobs a lot easier, and they're doing that to a point. But they now need to move to that next stage where, either seams evolve or they're augmented and eventually replaced with tools that do a much better, intelligent job of analysing the information.
Can I help answer that as well? Because the company I work for is large, and it is a lot of cost basis for the people. We're actually trying to create more skilled analysts, but you have to manage more devices significantly more. And the time to respond is short a long time now. When we started at an IDS about 10, 15 years ago, we were looking to see if you could do a response time of 15 minutes. 15 minutes is now a long time. It's that dangerous. So what you're looking at is developing larger SPLUNK as well. You've got to consider how much that can scale. It can scale massively. So for the bigger enterprises, it's how big can you go and how much can you manage. And if you manage, I guess you said a SOC, multiple organizations, customer organizations.
Yep.
So then how many of those could you manage? And that's the difference.
Yeah.
There's more.
So in our particular thing, we only manage in-house SOCs. So we're not an MSSP. We don't take people's data out and have a team of people. It's always in-house built SOCs. But yeah.
How do you think it's going to complement what we have now as control? So when you consider all the features it has as a feed, or the data inputs it could take as a feed, those are usually all from existing control levels at the network and the application layer.
So I think a product like UBA and other products that are coming through and are being competitive with it, they're to augment data collectors. So they're not there to replace the collection of the data, they're there to assist with the transformation of it into actionable intelligence. So it's not a SIM replacement tool, it's not a collector replacement tool. It needs to take a feed from a central type repository, whether that's based on Hadoop, MapReduce, or another SIM. That's what it needs.
How close do you think is it already from your use, your practice use of it? How close is it to the user? How close is it to the user machine?
Sorry, how close is it to?
Are you taking a feed, for example,
Yes.
from a gateway point, or are you
Yep.
taking a feed from a user's machine?
So not a feed directly from a user's machine, no. It's not what it's designed to do. Whether or not that changes, I don't know, but it's designed to take a feed from a collector of some form, whether that be Splunk or so that particular tool that's not Splunk specific. It can take feeds from QRadar or other big data type tools, but there's dangers in having a tool that tries to do everything, and especially when it comes to looking at your hardware requirements and how your resource allocation works, it's sometimes better to separate out and augment those layers.
Do you have any agent development, software agent development?
So within Splunk themselves, so they have the universal forwarder, which sits on endpoints for data collection. So yes, they do that. Yes, so Splunk Core Enterprise, so Splunk Enterprise, Splunk Cloud, etc. They support that and have them for years. So they can take it right from the endpoint, from your network tap, from a database. There's not many places they can't go in collection.
Okay.
It can get data from AS400, red tabs, or types of machines that are Windows based.
Yeah.
Thank you so much. We have run out of time. So any questions, you'll be able to get Harry
Yeah, I'll be around for about the next
later on.
45 minutes.
So thank you very much. Round of applause. Harry.